Hello and welcome to the final step of the development of part 2, mining our blockchain to turn it into a cryptocurrency. So in the previous tutorial we took care of creating an address for the node on port 5000, which is the port from which we'll start before adding some new nodes. Then we added the transactions key in the response of the mine block request, and we gave to these keys the transactions of the block which we could get thanks to the addTransaction method from our blockchain class, this one. So that was perfect. And now we have one final thing to tackle, and that is of course to make a new kind of request, which is a post request, to add a transaction to the blockchain. So first, let me remind you the difference between a GET request and a POST request. So you understand what a GET request is. It's basically when you want to get something, and to get this, you don't need to create anything. For example, when we mine a block, well, we get the response containing the new block that was mined, but to get that new block, we didn't need to post or create anything. And the difference with a post request is that we need to create something in order to get the response. And that's why it is called post, because basically we're posting something inside the HTTP client. And speaking of posting something, that's exactly what we'll do in this new request that we'll implement to add a new transaction to the blockchain. And it's because in order to add a transaction to the blockchain, well, we need to first post this transaction. And to post this transaction, we'll create a JSON file which will contain the keys of the transactions, that is, the sender, the receiver, and the amount of AdCoins exchanged. And that's exactly what we'll need to post. That's these informations that we'll need to post into the JSON file, and then the response will get this JSON file, and this JSON file containing the transaction will go through the JSONify function, and eventually this transaction will go to the next mined block. So let's do this request now that we understand what is a post request exactly. And to be efficient, I'm simply going to copy this line here, because in order to make this a post request, well, we'll actually need to replace two things. First, of course, the name of this new request, which we're going to call add transaction. And then, of course, as you might guess, the name of the method, that is the type of the method, which is no longer a GET request, but a POST request. Just like that. And there we go. We are ready to implement this new request. So same, we're going to do it through a function, which we'll define as simply the add transaction function, add transaction, and here we go. We are ready to define this function. Alright, so first, what are we going to do? Well, let's start from the general purpose of this function. This function has to basically create a transaction. That is, it has to announce a transaction by giving the sender, the receiver, and the amount of AdCoins exchanged. But how are we going to get these informations of the sender, the receiver, and the amount? Well, we'll get them exactly through the JSON file that we will post in Postman. So that means that in Postman, we will literally create a JSON file, which is exactly like a dictionary, in which we'll type the three keys, that is the sender, the receiver, and the amount, and of course their values. And in their values, we'll input for the sender the name of the sender, then for the receiver, the name of the receiver, and then for the amount, well, the amount of AdCoins exchanged between the sender and the receiver. And you'll see in the demo, I will actually be sending, I haven't thought about it yet, but something between 10 to 1 million AdCoins to Kirill. He'll be very happy. And literally to do that, well, I will create a JSON file where I'll input for the sender myself, Adlin, then the receiver, Kirill, and the amount, well, I'll need to think about it. And then once I create this JSON file, well, we will post it in Postman by, again, clicking on send, but by selecting the post request in, the drop-down of all the requests, and that will post the new transaction. That will create this new transaction. All right, so first what we'll need to do now is get that JSON file that will be posted in Postman, And to get it, well, first I'm going to introduce a new variable that I'm going to call JSON, which will represent the JSON file itself. So JSON, and how are we going to get the JSON file? Well, we're going to take our request library, and from this library, we're going to call the getJSON function. All right, so that will basically get the JSON file posted in Postman. Perfect. Now, the next step, well, we'll do a quick check to check that all the keys in the JSON file are present. That is, we're going to check if there is no missing key, because otherwise we'll get an issue. So let's do this quick check before, and to do this, I'm going to introduce a new variable that I'm going to call transaction keys, and that will contain the list of the 3 keys of a transaction. And these are first the sender, then the receiver, and eventually the amount. All right, so that's the 3 keys of a transaction that any transaction that is posted into Postman must contain. If a transaction is missing any of these keys, well, we'll return a warning or an error saying that something is missing, something is not right. All right, so speaking of this, that's exactly what we're going to do now. That's why I'm starting with an if condition to check that if not all the keys in our transaction keys list, if all the keys of this transaction keys list are not in JSON, well, we'll return an error. So you understand the syntax here? You have to read it this way. If all the keys in the transaction keys list are not in our JSON file, well, in that case, we'll return something like, in quotes, let's say, some elements of the transaction are missing. Or if you want, we can say again, Houston, we have a problem. As you want, but basically what you write here will appear in Postman whenever there is a transaction posted with a missing key. So some elements of the transaction are missing. Perfect. We check that, but we're not only going to return that message, we're going to use, of course, the HTTP status code. That's what they use for in case there is an error. And since this time we're dealing with an error, in case we are in this situation, well, what we'll return is, actually we can go back to Google, because remember we had this Wikipedia page containing the list of all the HTTP status codes open. And so now we want to check for the code of an error, which is this one, exactly this one, 400 bad request, which, as you can see, includes the situation of a malformed request syntax. And a missing key is exactly that, a malformed request syntax, or if you want, an invalid request message framing. But anyway, this is the HTTP status code for a bad request, and that's exactly what we need to return right here. All right, 400. And now if the transaction is okay, that is, if there is not any missing key, then let's do what we have to do, which is, of course, to add this transaction to the next mined block. And so now the question is, what is going to be this next mined block? How are we going to get it? How are we going to choose the right one to lock this transaction? Well, the answer to that question is the index. In order to find the right block to lock this transaction, we need to figure out what is the index of the next block that will contain the transaction. And again, I have some very good news. If we scroll up, we see that the addTransaction method returns exactly the index of the block that will contain the transaction. And therefore, it's a no-brainer. We don't have anything to do. We just need to call this method that will give us exactly this index of the next block catching the transaction, and we'll be good to go. All right, so let's do this. That's exactly what we have to do now. We're going to get that index by calling the addTransaction method from our blockchain object, right? Indeed, because addTransaction is a method of our class, so we need to take the self first. And here, since we are out of the class, the self corresponds to the object created, that is blockchain. And from this object, we get our addTransaction method, which takes as arguments exactly the values of the keys of the transaction. Right? Be careful. This addTransaction method doesn't take the keys, it takes the values of these keys. And so now the question is, how do we get exactly these values? Well, of course, we'll need to take the posted transaction, which right now is in the JSON format because we use this getJSON function to get the transaction in the JSON format. And the JSON format is exactly like the Python dictionary format. It contains some keys and values. So right now, in order to get the values of the transaction, well, we'll take our JSON variable, which is exactly the JSON file containing the transaction. And since this JSON file works exactly like a dictionary, well, we simply need to get here the keys, starting with the sender. And then I'm going to copy this because it's going to be the same for the other keys, that is the other values that we want to get. The second key is the receiver, but be careful, I'm getting here the values of these keys, and eventually the last key, which is the amount of AdCoins exchanged between this sender and this receiver. That is Adelin and Kirill in the demo. So there we go. We have our index. We have the index of the block that will contain this new transaction that we're adding to the blockchain. And now the final thing that we have to do is, of course, to return the response. And so what is this response going to be? Well, first, let's introduce the response variable, which will contain the response. So this response is going to be exactly a message saying the following, that our transaction that we're adding right now in this function, in this request, is going to be added to the block of index, and we'll specify that index. So that index, we have it right here in this line of code. And therefore, what we can do is the same as what we did previously when using the fstring Python 3.6 trick, the fstring syntax, which is just to include whatever string you want, then put this f first, and in brackets, you input the variable that will be replaced in the string once the string is printed. So that's exactly what we'll do here. And therefore, scrolling back down to our message in the response, well, what we'll do is start with f, and then let's not forget the quotes to include our string, and our string will be this transaction will be added to block, and that's where we specify the index in brackets. And inside these brackets, we just need to input the name of the variable that contains that index, and that is index. That is exactly this variable. Perfect. And now we are almost reaching the end. The end is to return, of course, the response in the JSON format, and therefore we're going to do exactly as we did before. We're going to use here the JSONify function, which will take as argument, of course, the response. And then let's also return our HTTP status code, which, be careful, is different this time because we are on a post request. And so if we go back to Wikipedia with all the HTTP status code, well, it's almost the same as the one we used for the GET request to still say that everything is okay, you know, that it's a success. But since we're doing this for a creation, that is for something that is created, well, it's going to be the code 201. And that's exactly what we'll return right here for the HTTP status code of our post addTransaction request. Perfect. So congratulations. Part 2 is done. We're actually almost ready to start the demo. I can't wait. The demo is actually going to be exciting. We're going to send a lot of AdCoins to Kirill. But to do this, we first need to decentralize our blockchain to connect some new nodes to our decentralized blockchain. And therefore, since we'll have several nodes, well, we'll need to make another request, which will be a GET request, by the way, to apply the consensus in case some nodes in the network don't have the most up-to-date blockchain. All right, so we'll make two requests. One connect node request, which will be a post request to connect any new node in the decentralized network, and another request to apply the consensus, replacing the chain in any node that doesn't contain the most up-to-date blockchain. So we'll do that in the next two tutorials. and then we'll start the demo. Until then, enjoy blockchains!